Hello everyone, hope you are safe and doing well. Today we will see different properties of divisibility and then we'll cover divisibility test for some numbers. So we'll start with first property of divisibility. If a number x divides two or more numbers, then x divides the number or difference or any expression involving addition or subtraction or both. For example, let's take 2. We know that 2 divides 2, 4, 6, 8, 10, 12, then 14, then 18 and so on. Right? So here 2 is x. Now if a number x or 2 divides two or more numbers, then x divides the sum or difference or any expression involving addition or subtraction or both. So if we write 2 plus 4, then 2 plus 4 is first expression involving addition. So 2 plus 4 is also divisible by 2. Or if we write 2 plus 10, then this number is also divisible by 2. Also, say 12 minus 4 is also divisible by 2. Or if we write 18 plus 14 minus 12 plus 6, all these numbers are divisible by 2. So this expression involving all numbers will also divisible by 2. This is first property. Second property, if x divides a number, then x divides the product of the number and any other number. Now for example, let 3 is a number. Now if x divides a number means, say 24 is the number, and we know that 24 is divisible by 3. So 3 divides 24. If x divides a number, then x divides the product of the number and any other number. So 24 into any number is also divisible by 3. Any number means any number. Just write 6 or write 24 into 4 is also divisible by 3, or you can write any number 24, because 24 is divisible by 3. So multiplication of any number by 24 will also divisible by 3. So 24 into 6 is also divisible by 3. This is your second property. Third property, if x is a composite number and it divides a number, then each factor of x divides the number. Let's take a composite number, say 12 is the number, 12 is a composite number and it divides a number. So say 48 is the number. So we know that 12 divides 48. Now property says that then each factor of x divides the number of factors of 12. Factor of 12 are 1, 2, 3, 4, 6 and 12. Then each factor of 12 divides the number. Let's check it. Each factor means 48 is divisible by 1, yes. Then 48 is divisible by 2, yes. So each factor divides that number. 48 by 4, yes. Then 48 by 6 and 48 by 12. So this is true. If x is a composite number, 12 is a composite number and it divides a number, that number is 48 here, then each factor of x, each factor of 12 will divides the number. This is the verification. Next property, if two coprimes are such that each divides a number, then the product of the coprimes also divides the number. For example, let's take 3 and 5 These are co-primes. Now, if two co-primes are such that each divides a number, so the number is 45. 3 divides 45, yes, and 5 divides 45, yes. So each divides a number, then the product of the co-primes also divides the number. Then product of 3 and 5 is 15. So the product of the co-primes also divides the number. Product will also divide this number 45. Yes, this is true. So this was fourth property. If two co-primes are such that each divides a number, here two co-primes are 3 and 5 and the number is 45, then product of co-primes 3 into 5 is 15 also divides the number. Yes. Next property, all numbers except 0 divide 0. True. Last, when x divides a number exactly, x is a factor of that number. This is also true. So these are 5 properties, and sixth one is a general conclusion for divisibility. Next, test of divisibility. These tests will help us to decide whether a given number is exactly divisible by these numbers or combination of these numbers or not without actual division. So for finding factors of a given number, we can go for these simple hints. First, for 2. If one's digit is an even number, then you can say that the number is divisible by 2. For 3, if sum of digits is a multiple of 3. For 4, if number formed by last 2 digits means ones and tens, on the right is multiple of 4. For 5, one's digit is 0 or 5. So if last digit, one's digit is 0 or 5, then you can say that the number is divisible by 5. Now for 6, the number is even. First condition is the number is even. Second condition, the sum of digits is a multiple of 3. Why 2 conditions? We'll check. Now for 8, the number formed by last 3 digits on the right is a multiple of 8. This is similar to 4. For 4, last 2 digits. For 8, last 3 digits. Then for 9, the sum of digits is a multiple of 9. Again, this is similar to 3. For 10, one's digit is 0. This is simple. For 11, the difference of the sum of alternate digit is, first condition, equals to 0 or a multiple of 11. And for 12, 15 and 18, check divisibility of all co-prime factors. Now moving to the exercise. Exercise 3.3. First question, test for the divisibility of numbers. First is, we have to test for 2. And given number is, first A, 1735. So this is the given number and we are required to check its divisibility by 2. So for 2, just check one's digit, whether this last digit, one's digit, is an even number or not. 5 is not an even number, 5 is odd number. So number 1735 is not divisible by 2. Answer is no. Then part C, the given number is 1, 1, 1, 1 and 2. Again we have to check last digit only. Last digit is 2. 2 is an even number. So this number 1112 is divisible by 2. Then part E, given number is 97990. Again last digit is 0. 0 is divisible by 2. So this number is also divisible by 2. Next question. Question number 2. We have to check for 5. Question number 2 by 5. First question A, 7, 3, 4, 5. Now for 5, we have to check again for ones digit. If ones digit is 0 or 5, then the given number is divisible by 5. Ones digit, last digit is 5. So this number is divisible by 5. Answer is yes. Then part C, the number is 1734. The number is 1734. Again, last digit is 4. 4 is not divisible by 5. So answer is no. This number is not divisible by 5. Next, part D, 234765. Given number is 234765. Last digit is 5. So the given number is divisible by 5. Answer is yes. Third question, by 4. So we have to check divisibility by 4. Part A, 9348. Given number is 9348. Now for 4, number formed by the last two digits on the right is a multiple of 4. So we have to check for last two digits. Last two digit means 48. Now 48 is divisible by 4. So this number 9348 is also divisible by 4. Answer is yes. Part C, the number is 17532. Again we have to check for last two digits. 20 is divisible by 4. So this number is also divisible by 4. Yes. Part D, the given number is 34728. Last two digit 28. Yes. Answer is yes. Now question number 4, divisibility by 8. Part A, the given number is 193128. Part C, 7500. And part D, the given number is 12576. Now for 8, the number formed by last three digits on the right is a multiple of 8. So we have to check for last three digits. 128. 128 by 8 is 16. So last three digits, this number 128 is divisible by 8. So this number is also divisible by 8. Now for 7500, last three digits 500. Is it divisible? No. So 7500 is also not divisible by 8. 12576. Again, last three digits. If you divide 576 by 8, you will get 71 or 72. 72. So this number is also divisible by 8. Question number 5. We have to check for 3. Divisibility by 3. And we are going to solve first part, part A, part C, and part E. So first number is 193128. Then part C, 7502. And part C, 10056. So these are 3 numbers. Now for 3, sum of digits is a multiple of 3. So if sum of these digits is a multiple of 3, then we can say that the given number is divisible by 3. So here we have to add all these numbers. 1 plus 9 plus 3 plus 1 plus 2 plus 8. 1 plus 9 is 10. 10 plus 3, 13. 14, 15, 16. 16 plus 8, 24. And if this number 24 is a multiple of 3, then we can say that this number is divisible by 3. So yes, 24 is a multiple of 3. So the number is also divisible by 3. So answer is yes. Next 7502. Again we have to add all digits. 7 plus 5, 12. 12 plus 2 is 14. And 14 by 3. No. So 14 is not a multiple of 3. So this number 7502 is not divisible by 3. Third number 10056. 1 plus 0 plus 0 plus 5 plus 6. 1 plus 5, 6. 6 plus 6, 12. So total is 12. And 12 is a multiple of 3. So yes, 10056 is divisible by 3. Next question 6. We have to check divisibility of given numbers by 9. Part A, part C and part E. First number is 2, 9, 3, 4. Second number 7, 5, 6, 9. And third number is 3, 5, 6, 7, 6. Now for 9, if the sum of digits is a multiple of 9, then we can say that the number is divisible by 9. So again we have to add these numbers. 2 plus 9 plus 3 plus 4. Total is 9 plus 2, 11. 11 plus 3, 14. 14 plus 4 is 18. And 18 is a multiple of 9. So this number is divisible by 9. Answer is yes. Next number 7, 5, 6 and 9. 7 plus 5 is 12. 12 plus 6, 18. 18 plus 9 is 27. 27 is also a multiple of 9. So this number is divisible by 9. Third, 3 plus 5 plus 6 plus 7 plus 6. 3 plus 5, 8. 8 plus 6, 14. 14 plus 6. 14 plus 6 is 20. 20 plus 7 is 27. Again, 27 is a multiple. So this number is also divisible by 9. Next question number 7. Divisibility by 12. Part A, part C and part E. Given numbers are 4, 5, 7, 2. 4, 5, 7, 2. Then 5, 6, 7, 1, 2. 5, 6, 7, 1, 2. And 7, 5, 6, 4, 2. These are given numbers. Now for 12, 15 and 18, check divisibility of all co-prime factors. So first we have to write co-prime factors of 12. For 12, we can write 3 into 4. These are co-prime factors of 12. Now if this number is divisible by 3 and this number is also separately divisible by 4, then we can say that the number is also divisible by 12. So we have to check for both cofactors. So checking for 3 first. So for 3, we have to add these numbers. 4 plus 5 plus 7 plus 2. So 4 plus 5 is 9. 9 plus 7 plus 2. So 9 plus 9 is 18. 18 is divisible by 3. 18 is a multiple of 3. So this number is divisible by 3. Yes. And then for 4. For 4, number found by last 2 digits on the right side is a multiple of 4. 72. Yes, 72 is a multiple of 4. So this number is satisfying both conditions. So the number is also divisible by 12. Answer is yes. Next 5, 6, 7, 1, 2. The number is 5, 6, 7, 1, 2. Again, we have to check for 3 and 4. For 3, we have to add 5, 6, 7, 1, 2. 7 plus 1 plus 2. 6 plus 5, 11. 11 plus 1, 12. 12 plus 9, 21. 21 is a multiple of 3. Yes. Then last two digits, 12. So 12 is also a multiple of 4. Both conditions satisfied. So the number is divisible by 12. Now for third number, 7 plus 5 plus 6 plus 4 plus 2. 7 plus 5, 12. 12 plus 6, 18. 18 plus 6, 24. 24 is a multiple of 3. Okay. And last two digits, 42. 42 is not a multiple of 4. After 40, we'll get 44. So, cross here. So, both conditions are not satisfying. So, the answer is no. This number is not divisible by 12. Next question, question number 8. We have to check for 15. First part, third and fifth. So first number is 3285. Third number 72355. And fifth number is 95355. Okay. Again for 15, method is same. Check divisibility of all co-prime factors. So for 15 we have 3 and 5. These are co-prime factors of 15. So again we have to check for 3 and for 5. If both satisfies, then we can say that this number is divisible by 15. So checking for 3. 3 plus 2 plus 8 plus 5. 3 plus 2 is 5. 5 plus 5 is 10. 10 plus 8 is 18. And 18 is a multiple of 3. So yes. And for 5. Now for 5, last digit must be 0 or 5. Last digit is 0. Yes. Both conditions satisfied. So this number is divisible by 15. Next number, 72355. 7 plus 2 plus 3 plus 5 plus 5. 7 plus 2 is 9. 9 plus 3 is 12. 12 plus 10, 22. 22 is not a multiple of 3. No. But last digit 5. So second condition satisfied, but first condition fails to satisfy. So the number is not divisible by 15. Third, again last digit is 5. So second condition is okay. And we have to check for 3. 9 plus 5 plus 3 plus 5 plus 5. 5 plus 5 is 10. 10 plus 5 is 15. 16, 17, 18. 18 plus 9, 27. And 27 is a multiple of 3. So, yes, answer is yes. This number is divisible by 3 and 5. So, the number is also divisible by 15. Now, next question, question number 9. By 11. By 11. Part A, B, Part A, C and E. First number 19768, then 475, 618, and 36157. These are numbers. Now for 11, the difference of sum of alternate digits is 0 or a multiple of 11. So difference of sum of alternate digits. Alternate means here we have to divide these numbers in two groups. First group, even group by position, and second group, odd group. These are on even place, and these numbers are in odd place. So 1, plus 7 plus 8, 1 plus 7 plus 8 minus sum of 9 plus 6. So 1 plus 7 is 8, 8 plus 8 is 16 minus 9 plus 6. 9 plus 6 is 15 and 16 minus 15 is 1. Now this number 1 is not a multiple of 11 and it's not 0. So this number is not divisible by 11. Answer is no. Again for third part, 4, 7, 5, 6, 1, 8. Just write numbers on even places and on odd places. 7 plus 6 plus 8. So first number, then third number, then fifth number. 7, 6 and 8. Second, fourth and sixth from this side. And the difference is 4 plus 5 is 9, 9 plus 1 is 10 minus 7 plus 6 plus 8. 7 plus 6 plus 8 is 21. So 10 minus 21 is minus 11. No matter whether the final number is positive or negative, if this number is a multiple of 11, then we can say that the number is divisible by 11. So yes, it's a number, it's a multiple of 11, minus 11. So the number is divisible by 11. Last 3, 6, 1, 5, 7. 3 plus 1 plus 7 minus 6 plus 5. So 3 plus 1, 4, 4 plus 7, 11, 6 plus 5, 11, totally 0. So sum of alternate digit is 0. Yes. So this number is divisible by 11. Next question number 10. Write true or false first. A number which is divisible by 3 is also divisible by 9. So the answer is no, false, because it is not possible for all numbers. If that number is divisible by 3, then it may or may not be divisible by 9. Let's take 6. 6 is a number which is divisible by 3, but 6 is at the same time 6 is not divisible by 9. So the answer is false. Then part B. A number which is divisible by 9 is also divisible by 3. This is true. This is true because 9 is a multiple of 3. Right? 3 into 3 is 9. So 9 is a multiple of 3. So for all numbers, if that number is divisible by 9, then that number will always be divisible by 3, because 3 is a factor of 9. So second statement is true. Next, question 11. Fill in the gap in each number with least possible numbers so that part A, part C and part E. 137, then missing number 8 is divisible by 3. See, 978, missing number and 65 is divisible by 11, and 953, missing number, is divisible by 4. So this is missing number, and last digit is missing. In the first part, 137, missing number and 8. So say this number is x. Now this number is divisible by 3. For which value of x? or which minimum value of x this number is divisible by 3. For 3, the process is we have to add these numbers. So 1 plus 3 plus 7 plus x plus 8. If this number, this total sum, is a multiple of 3, then we can say that this number is divisible by 3. So we have to find least value of x. So 1 plus 3 is 4, 4 plus 7 is 11, 11 plus 8 is 19, 19 plus x. Now multiples of 3, 3 is 6, 9, 12, 15, 18, 18 is less than this number, and after 18 next multiple is 21. So the least value is 21. Next multiple minus 19. Answer is 2. Or just try to assign value of x such that the total becomes 21. So the answer is 2. So least value or least minimum value of x is 2. Answer is 2. Part C. Next number 978. Say missing number is x. 65 is divisible by 11. So for 11, the difference of sum of alternate digits is 0 or multiple of 11. So sum of alternate means 9 plus 8 plus 6 minus 7 plus that number plus 5. So 9 plus 8 plus 6 is 8 plus 6 14, 14 plus 9 is 23 minus 7 plus 5 is 12 plus x. Okay. Now if this total becomes 0 or multiple of 11, then this number is divisible by 11. So for value of x, or value of x means 23 minus 12 minus x must be equal to 0 or 11 or 22 or any multiple of 11. So here 23 minus 12 is already 11. So the minimum or least value of x is, so for 0, this for 11 value of x will be 0. So 0 is the least value of x. Next 953, missing number is x again, is divisible by 4. So for 4 we have to check for last 2 digits. Last 2 means 3 and x. If last 2 digits, this number is divisible by 4, then we can say that this number is also divisible by 4. So 30, 31, 32 and so on. 33, 34, 36. This is divisible by 4, but we have to go for least. So this is the least number. So least value is 2. So the answer is 2. 11th question is over. Now question number 12. Find the remainder when 9 divides the following numbers. These are numbers. Now for 9, the sum of digits is a multiple of 9. So sum of digits will be a multiple of 9 for divisibility. So 7 plus 5 is 12, 12 plus 6 plus 4, 10, total is 22. And multiples of 9 before and after 22. First multiple is 9, second multiple is 18 and third is 27. So after 18, next number or the total of these digits is 22. So the difference of 22 and 18 will be the remainder. So here 22 minus 18 is 4. So remainder is 4. Again for second question, 7095. We have to add them. 7 plus 0 plus 9 plus 5. Total is 7 plus 5, 12, 12 plus 9, 21. So after eating the difference is 3, and that 3 difference between total and least multiple is also the remainder. So if you divide this number by 9, you will get a remainder of 3. Last 3, 9, 4 to 5. 3 plus 9 plus 4 plus 2 plus 5. So 9 plus 3 is 12, 13, 14, 15, 16, 17, 18, 19, 20, 23. 23. Again, 23 minus 18 is the answer. If you divide this number by 9, you will get 23 minus 18 equals to 5 as remainder. So this is all from my side. Please solve all the problems of this exercise in your notebook, and if you have any problem, any doubt in any of the question, please write in the comment section. Thank you.